here in the New to You Speakers Workshop. We have another speaker project, and I actually started in on this pair already because I wasn't quite sure what I was going to find, and I did find some interesting things that I think will make this an interesting video. This is the Utah HS4-B.
Whoa, Nelly!
It's time to stop before we go any farther in this video and make a correction. This is not a Utah HS4-B. This is a Utah HS1C. Now, when I purchased them, they were advertised as HS4-B. They didn't have the paper label on the back, and as I started a couple clues started happening to me as I started taking these apart further and started, checking some photos on the internet and looking up some data about the speaker. The first clue that I didn't pick up on is the orientation in the cabinet. So what I've seen since investigating this is that the orientation of the tweeter and the mid-range were different on the HS4-B. The mid-range horn is mounted kind of in this orientation with a port and tweeter. The other clue was that the write-up of the HS4-B said that it was a flared horn tweeter. Well, this is not a flared horn tweeter. This is a standard, paper conical tweeter. It doesn't have a waveguide. And then I started looking at HS4-B photos. Of course, there aren't many pictures of the HS4-B with the grill covers off because you have to disassemble the whole thing. But I did eventually find a couple photos, and they in fact have a plastic waveguide and not a sealed back. So the key for the HS1C is sealed back tweeter, mid-range horn, compression horn is up here at the top and not on the side. And so that means that these are probably not from 1974, 1975. They're probably closer to 1970, 71 timeframe. So we're going to get into more of that when we talk about Utah as a company and how they got to be what they became. We're also going to, I think the other unique thing is this mid-range horn, or the compression horn. So compression driver. We're going to take a look at maybe a little more detail about a compression driver. We have not talked about that on the channel previously, but essentially this is your voice coil. It's large, and then it pushes all the air through an opening, which is small, and then using the horn shape, deploys that sound. That has some unique properties, so we'll take a look at that also. All right, we're going to keep going. If I do mistakenly say HS4-B anymore during this video, I really mean HS1C, so I hope that's clear. The boxes are really well made. Nice walnut veneer over particle board. Very heavy boxes, so I like them a lot. We've got a nice reveal line here where you would think that has something to do with the grill coming off, but the grill does not come off from the front. You have to basically take the baffle board out from the back. So we'll dig into them a little bit. They've got some dings and scratches, and we've got some veneer repairs to do, and so there's some paint drips on the grill cloth, but I think we'll be able to clean those up just fine. What was the most interesting was what I found when I opened these up. I knew there was a horn driver in there. I wasn't quite sure what else to expect. These are known for being pretty bassy. And there's an interesting, not too well detailed history about Utah, but I was able to find some interesting information. let's spin them around and then take a look at the backs and the insides, since I've already done some disassembly and taken some measurements. All right, here you can see the back of the case. I pulled all the screws on the binding post area. We have just a simple screw terminal and then a pot which says increase and goes from 1 to 9. And once we look at the crossover, we'll see what's involved in that. This box, you can see I've actually already removed all the drivers. And what we have up here is mid-range horn, tweeter, a port, and then a 12-inch woofer. Interestingly enough, there's only a small amount of fiberglass batting here on this side and on the bottom. Nothing on this side and nothing on the top. I found that to be a bit odd. But I'm not sure this is a tuned port either. It's just a cardboard ring. You know, what is that, 3 or 4 inches? And it's not really clear how that's intended to work. There's a divider line, you know, particle board here, a dividing piece to help probably support the grill cloth. And we'll take a look at the other one here in a second. So I think pretty straightforward. So there's some possible improvements you can make. You know, it's 3/4 inch material, veneered on the inside also, which is noteworthy. Let's go over to the other speaker. We'll pull this back cover, and I'm going to have to do some repairs on these where the screws were driven into the particle board, and then when they were backed out, some of the particle board flaked away. You didn't get a clean hole like this, so that'll be a little bit of repair. Let's start with, I've disconnected all the crossover wires right now. I'm going to pop up a picture of what it looked like before all the wires were disconnected from the driver. But here you can see we've got a small resistor, we've got a cap, and this is the pot for the attenuation. And it turns out the way this is wired, I may create a crossover diagram so you can see exactly what this is, but I believe the mid-range and tweeter are controlled, both are controlled by this pot. And I guess I have to check the wiring on this cap also, see how that's intended to be run. But they were both identical. They were both wired identical, same wire, same connection. And I've also taken measurements on all the values. But let's take a look in the box for a little seal, a little foam seal going around the perimeter, probably just to help dampen vibrations of this back cover. So fairly straightforward. I've left 1 screw there. There were 4 screws holding that on, so you just don't see that. So I'm sure we'll end up replacing this crossover. We'll probably clean the pot, and that'll be a little more obvious in a minute. So here's what the 3 drivers look like. We've got a compression horn driver up on the top. This is actually the mid-range. All right. We've got a tweeter, and then this is the woofer. Let me do a quick zoom in here so you can catch the part numbers on these. I'll just try to pause so you can see that. Part numbers on all the drivers. I believe these are also date stamps underneath the part numbers. All right. So it's a fairly basic 3-way speaker. Now, what was interesting was when I took all the measurements. Let's make sure we'll flash up a photo of the measurements I took. But the resistors measured 8.7 and 9.1 ohms. I'll have to read the color coding on that to see what it's supposed to be. The capacitor measured 5.2 and 5.3. They're marked as 4. um, the variable resistor, which is on the, right, this is essentially a variable resistor pot that measured either 0 ohms at one end or 153 ohms on the other end. So that's, and that both of them measured identically, which is fascinating. Woofer measured 6.6 ohms of resistance on both. The mid-range measured 9.5, and the tweeter measured 9.5 ohms, and the horn measured 10.4 ohms on both. So everything's fairly consistent. And I thought, okay, there's really not much to see here. It'll be a basic clean up the boxes, update some of the electronics, do some cleaning, listen to them, and go from there. But when I pulled this woofer, and there's 4 nuts back here holding this to the baffle plate, I found something interesting, and you see it right away. And when I pulled this out fell the vertical support brace, which had been broken, and then we also have some damage. So here you can see it's a paper cone and paper surround, and it's got one tear, 2 tears, and some roughage, another tear, and another tear. And this was mounted in a position that what happened was something hit into the front grill cloth from the outside pretty hard, broke this. Okay, this piece goes down here, this piece goes up here, broke this center support, which is just, particle board, and pushed on it hard enough that it actually broke the cone. So that's going to be, I think, the most noteworthy part of this video is going to be repairing a paper cone surround. And we've done a paper cone repair where the surround was not affected. We've shown that in one of our other videos. But this time we have the surround is affected, and that needs to flex. So we now have an area where we want some rigidity, but here in the flexing area of the cone, we need flexibility. So we're going to attack that, and we'll have to acquire some, round up some proper glues and materials, and then we're going to go at this. And here you can see this is just remnants of the particle board that were on there, and all the dust has been collected down here in the bottom part of the cone as well. So that's going to be a new challenge for the channel. We'll show you how to do that, and there's a variety of there's a couple of videos out there that show how to repair paper cone surrounds, and let's get at it. All right, the first job we're going to work with here is gluing in this center support. So I think this is a Gorilla Glue job. I did a test fit. The 2 pieces fit in there perfectly, and when you wedge them in, it provides all the perfect kind of pressure. So we're going to have to put a paper backing so we don't glue the fabric to our patch, because Gorilla Glue does expand. So we'll slip probably some wax paper in there, and we'll show you that. That's next. Gorilla Glue cures effectively with moisture, so we're going to spritz a little water into the ends that we're going to glue. Hopefully our Gorilla Glue is still good from the last time we used it. That's always a question with Gorilla Glue. I've just put a piece of parchment back here. Hopefully you'll be able to see this with my arms in there. Here's the bottom, here's the top. So this is just so our Gorilla Glue expands, it won't force its way out into the grill cloth. So this is basically a do-it-yourself clamp also. And we're just gonna push this in. That's really all there is to it. I also realized I forgot to mention removing the baffle. I don't have a need to remove the baffle board with the grill cloth, but some of you may if you have a pair of these and you want to recover them. But we've got 3 screws on the top, 3 on the bottom, and 5 along each edge. 1, 2, 3, 4, 5. If you pull all those 16 screws, you'll be able to pull the baffle out. Actually, it goes out the front. So that's. But our cloth is in really nice condition, other than those paint drips that are on there, and we'll pluck those off, and it should be good. I see the cloth is stapled, so it's stapled onto the baffle board. Baffle board is not all that thick. It's it's only 1/2 inch, maybe 5/8 particle board. So there's an option, I think, to add some bracing to this box as well. But since it has such a large open port, I'm really not. It's not like it's an acoustic suspension speaker, so we're not counting on the sealed volume of the box to provide our bass. We're counting on the port. We'll do that, and if we have some other, I'll have to listen to them, and I may decide to come back in here and add some bracing. You could add bracing from this wall to the baffle, from the baffle to this wall. It's tough to do bracing on the back because it has to be removed, but you may just want to put some ribs, additional ribs of wood across here and stiffen it up a little bit. That might be another thing that you could do. We'd work on the crossover next. I pulled the knob, the little dial plate, and give me a little better access to get in here and clean this, clean the internals of this pot. So let's do that next, and then we'll let that all dry up, and then we may shine this up a little bit, clean it. Oh, we've got a couple of access points here. And from the top also. And then, of course, the key is work it. So I didn't hear any scratchiness to it, but this is a good thing to do regardless. And since I think the measurements are all look good, again, 0 ohms on one end, 153, both of them measured identically. So I think that puts us in a good shape. I try to do 40. I know it sounds like a lot, but this is one of those things you don't want to do it twice. Yeah, we'll hit the terminals here a little. Okay, backside looks all right. All right, we're going to take a measurement on, actually, let's get the color code. Brown, green, black, silver. So let's look that up and see what that resistor is supposed to be. All right, perhaps a little difficult for you to see, but in there we've got brown, green, black, silver. And brown, green, black, silver is 15 ohms, 10%. And we measured, let's see, this one is, we measured 8.7 on this one. So that's off. I'm going to have to go and see if I can find some additional information on what was intended to be there. And, it's always possible somebody was in here modifying this and tried to do something, but may or may not be able to find out some other history. Just get you a close up of the capacitor that's there. 4 microfarads, 50 volts, non-polarized. There's a bunch of part numbers that probably would tell you who made it. So we'll probably end up replacing that. It measured 5.2, and the other one measured 5.3. So, and the ESR is a little bit high, so we'll probably change that out. But a little more research to do, and then we'll start snipping and soldering. Did a little more checking. I can't confirm the crossover. There's one person on the internet who posted a photo of the crossover. They used a photo bucket. The photo bucket server is no longer serving their image, so I can't go there. What I'm going to do is I'm going to put these back together just with the new cap. Everything's cleaned. Then what we'll do is we will listen, and we'll run a frequency spectrum on them. And if we think they're a little too bright, because I did confirm that only the woofer, actually the woofer's playing full range, which is pretty amazing. And the mid and the tweeter are running through the variable pot and the fixed resistor here. So what we'll do is we'll listen to them and we'll run a frequency spectrum, and we'll see if there's a little peak or a hump somewhere that the resistor may help knock down. That's how we'll handle it for now. So we may come back in here, but for now we're just going to leave it as is. Here's our woofer. We're going to end up with a 3-step process here. Let's take a kind of a closer look at what our damages are. So I hadn't seen this before, but our dust cap has a dent, and it's part of the damage that was caused when the impact happened. We want to stiffen that up and prevent any other problems with that. That's going to be our white glue. The white glue dries rigid. We have another video where we fixed torn surrounds like this, and we're going to do white glue on this crack up until this first roll. We're going to do white glue on this area up until the roll, where the accordion pleat starts. This little tear right here, that doesn't go all the way through, so I think it doesn't go up to the peak of the roll, so that's in the flex section. So this is the stiff section, and then where the accordions are, that's the section that needs to flex. So we need to use flexible materials here, and it's okay to use stiff materials here and on the dust cap. We haven't lost any paper, so we don't need to do any patching with coffee filter or tissue paper or anything like that. So we're going to have a flexible glue, flexible adhesive to repair and patch these seams and bring these together. We're going to have a more rigid glue for the cone. And then what we're going to do is we're going to recondition the entire surround so that we keep flexibility in the accordion pleats of the paper. Our 3 materials we're going to use today are E6000. We're going to use that on all the areas that need to stay flexible, where we need an adhesive seaming process to bring these edges together. We're going to use standard white glue, PVA white glue, on all the rigid areas. So this cut right here, a little bit of this one, a little bit of that one, a little bit of this one, and down here on the dust cap. And then, perhaps something you haven't seen before, we're going to use 1 coat of thin coat of contact cement all the way around the surround. And we're going to end up doing this on the other woofer as well, just to bring flexibility and softness and prevent future damage or cracking. And one coat of the contact cement will do that. You might think, well, what are you going to bond something to it? No, we're not going to. It's going to actually stay tacky. Now, I do have liquid butyl, essentially surround sealer, which is used on things like KLH woofers. Some of the Advent woofers need that. Some of the AR woofers need that. And you can also buy surround sealant from Simply Speakers. That's available there. But I've found that the contact cement, a thin layer of that, works equally well. So we're going to use that on these Utah speakers. And by the way, you know, the underside, my understanding is Utah made Fender drivers for Fender amps, and this has a very Fender look to it. You know, there's really only one area here where you have full access to the cone, and then the rest is ribs, and it, you know, provides a little more stiffening. I would assume they have a reason for that design. So that's where we're headed. It also limits our ability to get to the back side of the cone a little bit, so we'll have to reach through here with our fingers or a Q-tip when the time comes to ensure that these areas, I'm reaching with my pinky up into this zone here, and we need to bring these two edges together. And you can see I'm pushing on the underside through one of these cutouts. And we'll need to do that to work the glue and into the backside. We'll probably even smear some of the glue onto the backside as well. So the repair won't be done just from the front, but also from the back. So we've applied some of the E6000. We may have to put a little bit on the backside as well. And we want to essentially assure that we have good contact across the crack. So we're pushing up from the underside. I'm using this little model paintbrush to smooth out the E600, working it in both directions. We'll go right up to the roll. Go up to the peak of the roll. And this dries clear, so actually when we put the contact cement, it's going to change the color a little bit too. So Q-tip, we'll reach up from the bottom through the opening, ensure that our two surfaces are level. So this E6000 is spanning the crack that we have. One. You want to keep it thin. You don't want it to bunch up. So we're just kind of spreading. Next crack. Any excess that we have, we're wiping off. Keep my hand out of the way so you can see better. And then here's our last one. you know, cosmetically, this is perhaps not as pretty as you'd like it to be, but it is effective. Okay. This one's hasn't sealed yet. I think we're going to go on the underside on this one. The two sections of paper aren't fully lined up. You won't be able to see this, so I'll just work it and take a look at the end. Just get a little bit more material on here. And we'll go in. Again, I'm trying to keep the E6000 only on the flexible part. We'll come along later and we'll put the white glue on the part of the cone that we want to stay rigid. So I think we have, let's put a little bit more in this one spot here. All right. Key is keeping everything flush and level. So let's come up under here, make sure that we're flush. And I think we'll add a piece of tape also to span that. Okay, that one looks good. There. This one, maybe one more poke. So what I'm doing is I'm poking the underside of the ribbed area, the ribbed paper accordion pleat, and I'm making sure that the surface to the left of the crack and to the right of the crack are even and level. And once we've got that, it should. All right. We're all leveled out now on our surround. Our E6000, let's clean up with acetone for that. Now we're going to move on to the white glue to do the rigid areas. Here's our white glue mixture, 1-to-1 water and white glue. And we'll just essentially paint this on the areas that we're concerned about. And we've got several cracks here that we want to make sure that we can go right up to the rolled edge. Little ding right there. And this is a very thin coat. I will end up going on the underside here as well. All right, I think that's all we need. Let's just make sure that's leveled up from the underside. Yeah, let's go on the underside. Probably nothing you can see, but we're going to do it anyway. Step 2 is now done. Let's move on to step 3. This just has to dry. That's it. No open flames. Make sure you don't have any of that. I've stirred it. I believe the more I thought about this, why would you not use the more advanced, I guess, materials for doing this repair? Well, this is not a high-end audiophile speaker, in my opinion. And what it is, however, is a nice speaker that you might find. And if you find one, I'd prefer to have you be able to use what you have in your home already to fix things. That's part of the frugality that I try to bring to this channel. And contact cement is a little bit more available, let's say, than, and you might have some already. So that's part of the reason that I'm using this material. I believe I learned it from on YouTube. If you look up Uncle Doug, I believe he has a video where he does a repair and a refreshing of surround with contact cement. And I know it looks extremely unconventional, and it is. So you can see what I'm doing is I'm going right up to the edge of the roll, right up to the peak of the roll. That's where your flexing is really going to start. So let's work this. I'm trying to be a little more careful in this area where we've done our seaming repairs with the other glues. And then the rest, we can be a little more free with it. It goes on, with the typical beige, gray, a little off color, but it dries clear. And it will stay a little tacky. And that's how you know it's still flexible, right? All right, I'll finish this up. I'll show you when we're done. And actually, I'm going to do the other one also. While the woofer's drying, I thought we'd clean up the paint spatters. Our process, I've done everything but this one. I wanted to take the worst one and show you our process. We start with wire brush, remove any loose material, and we pick with a blade, pick off what we can. Try not to use solvents. Sometimes you can get some staining from that. And then we come in with what's left over with our furniture markers, and we kind of need that blend of colors on this kind of cloth and do some final touch-ups of any things that are so embedded that we can't get them out. We don't want to cut or break any of the threads, but we want that to be gone. So let me get on this. Okay, that upper drip is now just about gone. The last bit of that, which you can see right above the point, I'll cover up the other ones. So that last little bit right at the point of the knife, we'll do that with the Sharpie. Basically, what you're doing is you're getting off all the hardened solid paint. It's not attached to the threads. And so you can pluck that off and come right in, and we'll do all those, and you'll see the result. There's our after. So I think we're looking good. The zone was right in here. Yeah, you may be able to see something a little dark. I'd probably use the black a little too much and not quite enough walnut, but from 3 foot distance, nobody's ever going to see any of that. I also forgot to show you, this is the same box that had our center support repair done. We can pull out our parchment paper, which protected the cloth from adhering to our center support, but that's ready. So woofer can go back in now that everything's dried up. And, it's one of those things, this speaker, since the grills are not removable on this, it, how pretty the driver is isn't really going to matter. So it's still got to dry a little bit more. Um, but we'll let it finish that, and that can all go back together. There it is. Let's begin our first sidebar and talk a little bit about the compression horn and compression driver. So Wikipedia is not a bad place to start. Here you see the information about a compression driver, and you can see this one here looks quite a bit like ours. And there's some history here, which turns out to be fairly meaningful. So in 1924, this guy named Hanna and Slepian determined that if you make the proper arrangement between the size of your diaphragm, the amount of volume of this chamber, and the size of the opening of the chamber where the horn emits the sound, you can get some interesting things to happen, some good things to happen. And so that learning became the foundation for compression horn drivers. Here is the patent, US 162-3561A. Here's an image of what they created. Mr. Joseph Slepian and Clinton Hanna. They worked at Westinghouse. And if you dig into the details of the patent, here are those details. They go on to explain why this is so important and why it works so well. Trust me, I'm going to spare you the math associated with this, but this is kind of the secret formula that they developed. And, well, it's not a secret anymore since they put it in a patent, but essentially what it says is you have a moving diaphragm and you have an opening in this chamber. And if you make the volume of this chamber and the opening in the chamber where the sound and the air comes out, make the ratio of the chamber size, diaphragm diameter, your excursion of the diameter of the diaphragm, the opening size here, make those all in the right proportion, and you can get high sound volume with low distortion. That's really what it comes down to. And it's because the air chamber with the small opening acts like dampening. You're basically creating a cushion that you can't force all the air out through the opening as if you had, an open cone, but that chamber creates a dampening effect. So the pressure builds up in there just a little bit before the sound is coming out, and that dampens the diaphragm and causes reduced distortion at equivalent volumes, and you can control what frequencies this happens at by the sizes of what you pick. That's what all that patent talks about. And so I suspect that the design of the Utah driver is quite amenable to this approach, and they optimized it in their design using these concepts. All right, as I started to poke around and try to learn more about Utah speakers, I came across this page from Joe Roberts. He's collected some information about Utah speakers, catalog pages, etc. I couldn't find specifically the HS4-B information here, but it led me on to just do some general searching, world radio history, and I finally pulled up some pictures of catalogs. You can get a lot of information about the HS4-B. And as soon as I started looking at the images here, I saw things like this over here. Here's the HS4-B
without the grill cloth, and I thought, well, this isn't what I have. And so you start poking around here on the Google Images a little more, and you start to see other configurations. And then I saw this one, the Utah Heritage HS1C, and that's exactly what we have in ours. So this is just a variety of images that I was able to find. This is the label that my unit doesn't have, right? We don't have this HS1C label on ours. You can't see the whole thing. Here it is, HS1C. We've got the full tone control here, but we don't have this label on ours. So, and by the way, this also shows the waveguide. This picture here shows the waveguide that's on the HS4-B, which is not our tweeter configuration. And this is when I realized I had to make the corrections to the video. Anyway, as we started looking for more information about what we now know to be the HS1C, I went through all I looked through the Radio Shack catalogs, the Allied Radio, Lafayette Radio. I just could not find where they sold the HS1C through any of the normal retail outlets. They may have. I did find the HS1B, but not the HS1C. But as I was poking through the various sources, I did find this one thread. Now, it's interesting that this is on the Polk Audio Forum, and about all you can find on the Polk Audio Forum, or the only place you can find this kind of historical information about the Utah company, is in the Polk Audio Forum. And it mentions that the company is founded by Francis Lester Pyle, born 1912, and he formed it in 1962, went out of business in 71. But then, if Pyle sounds like a familiar name, it is. Frank Pyle went on to form Pyle Industries. Now, that company name, not the same company, but that brand name is still used in equipment today, mostly fairly low-end electronics and etc. You'll note that it also talks about some of the drivers that they used were mostly cheap. They made drivers for a lot of other companies, maybe under other brand names, and I think that you can see that if you look in some of those old radio catalogs. But I think probably the main thing they were known for are the compression drivers. I followed some of these other threads, and it talked about how the compression drivers and those horns were reasonably nice. So I think that's part of why our system does sound so good, is that key compression driver on the mid. You see that detail. Some of their compression drivers may be an exception, and the exception is pretty much junk, the rest of it. I'm not going to go into details, but I wanted to show you our wood refinishing process. So we did an alcohol wipe, quick touch sanding. We used our floor wax filler sticks, Howard's Restore Finish, and then feed and wax. We've completed that on both of our boxes, so we've got beautiful looking walnut now, and I think we're ready for the final step of well, I got to think about whether or not I'm going to spring for some badges for these. That's also something to think about. I think they're about $10 for a set of two. It's now time to collect some data and see what the spectrum plot looks like. So here's 3 frequency plots. Let's compare the top 2, which is the repaired woofer, to the bottom one. And starting with the top plot versus the middle plot, This is the high frequency attenuator set at 1 versus 9. So you can see above 4K, it really helps keep the high frequencies up. On the other hand, let's look at the low end, and you'll see that there's really no difference between the repaired woofer and the non-repaired original undamaged woofer. So this shows that I think we've had a good result.